Hey everyone, welcome back to the Props.Lad YouTube channel. In this video, we're going to be diving deeper into the sample space. For those of you who may have missed it, we covered some basic terminology in lesson 1.2 that may be beneficial to review before going forward. Those terms, including sample space, are some of the fundamental building blocks for a beautiful journey through probability. Please feel free to check out the link in the description below if you need to catch up or rewatch lesson 1.2. So anyways, let's move on to the topic at hand, the sample space. To review, the sample space is traditionally represented as a capital omega. It represents a set of all possible outcomes of a random experiment. Today we're going to be quickly reviewing a handful of different situations and identifying the sample spaces for each. Keep in mind that sample space has the potential to get more complicated than the basic examples we'll cover today, and we will dive deeper into more advanced examples in future lessons. Let's first start off with a very simple experiment. Say we're flipping a coin. There are two sides, heads and tails. The possible outcomes of the experiment are limited to one of these two sides. The sample space is therefore heads and tails. Pretty simple, right? Now let's reinforce this with a second example using a dice roll instead of a coin flip. Our experiment will work with a six-sided dice numbered 1 through 6. The sample set shown then becomes all the possible rolls you can get in our experiment. Okay, so that wasn't so bad, right? It's time to pick it up, but just a little bit. Instead of using one coin flip, the experiment will now use 2 coins. We will flip the coins one after another, and an outcome of the experiment will be represented by the results of both coins. With this in mind, we can represent the sample space as follows. For our last example, we will be combining the coins and the dice. In this experiment, there will be 2 coin tosses and 1 rolling dice. Looking back at example 3, I'm sure you guys are realizing that this example is going to have way more terms in the sample space than our previous examples. In the interest of time, I'll skip writing out every possible outcome. Instead, let's try to see if we can understand the length of the sample space, or how many possible outcomes there are. This is a good exercise to review and solidify our understanding so far. So when working with sample spaces, you can multiply the sample sets within the larger experiment. So we can label the coins as omega 1 and omega 2. We can label the dice as omega 3. From our previous examples, we know the sample spaces for each of these. We can therefore find the number of outcomes as shown here. So now that we've touched on those examples, you're probably wondering what we can do with this. It's actually quite beautiful and a bit complicated, but we'll start simple for the sake of a motivating example. We know the sample space of a coin flip from before. Let's say we want to find the probability of an outcome. Looking at the sample space, we can say, hey, let's find the probability of getting heads. From intuition, you can probably guess that the probability of getting heads on a normal coin is 1/2, or 50%. And there you have it. You've already calculated your first probability. Of course, we're going to be diving into much cooler stuff soon, but this is a great place to start. If the coin example confused you, or if you're looking for an unfair coin or something more complicated, do not worry. We're going to be building on this material as we go, and it's only going to get more beautiful. Well, that's it for today, guys. I hope you guys enjoyed this video and found it interesting. If you have any questions, please leave them in the comment section below. And be sure to like and subscribe to help support the channel. Thanks, and I will see you guys next time.